Plastic. It's everywhere. From the phone in your hand to the car you drive, plastic products are ubiquitous in our modern world. But have you ever stopped to think about how these versatile objects are made? The answer lies in a hidden world of precision engineering and ingenious design, the world of plastic molds. These unsung heroes of manufacturing are the secret behind the mass production of countless everyday items. A plastic mold is essentially a hollow form, a meticulously crafted cavity that dictates the final shape of a plastic product. Think of it like a cookie cutter, but instead of dough, we're talking about molten plastic. This liquid plastic is injected into the mold under high pressure, where it cools and solidifies, taking on the exact shape of the mold cavity. It's a fascinating process that combines science, engineering, and a touch of artistry. But plastic molds are more than just simple cookie cutters. They are complex tools, often consisting of multiple parts that work together in perfect harmony. The design and construction of these molds require a deep understanding of material science, thermodynamics, and mechanical engineering. It's a field where precision is paramount, and even the slightest imperfection can mean the difference between a flawless product and a manufacturing nightmare. In this exploration of plastic molds, we'll delve into the fascinating science behind their design and operation. We'll uncover the different types of molds, their unique applications, and the crucial role they play in shaping our world. From the mundane to the extraordinary, plastic molds are silently shaping our future, one injection molded product at a time. The world of plastic molds is surprisingly diverse. Just as there are countless plastic products, there's a wide array of molds, each tailored to a specific manufacturing process and product type. Let's break down some of the most common types and their unique applications. First up, we have injection molds. These are the workhorses of the plastic industry, responsible for creating a vast majority of plastic products we encounter daily. From Lego bricks to car dashboards, injection molds excel at producing high volumes of intricate parts with excellent dimensional accuracy. They operate on the principle of injecting molten plastic into a closed mold cavity. Next, we have blow molds, the masters of hollow plastic objects. Think bottles, containers, and even kayaks. Blow molds use a fascinating process where a heated plastic tube, called a resin, is inflated inside the mold cavity, taking on the mold's shape as it expands. Finally, we have rotational molds, the giants of the plastic world. These molds are used to create large, hollow objects like storage tanks, playground equipment, and even kayaks. Rotational molding involves heating plastic powder inside a rotating mold, allowing the melted plastic to evenly coat the mold's inner surface. Each mold type plays a crucial role in shaping our plastic world, offering unique manufacturing capabilities for diverse product needs. Of all the plastic molding processes, injection molding stands out as the most prevalent and versatile. It's a carefully choreographed dance of pressure, temperature, and timing, resulting in the creation of millions of plastic parts every day. But how does this intricate process actually work? Let's break it down in simple terms. Imagine a large syringe filled with molten plastic. This syringe represents the injection molding machine, the heart of the operation. The plastic is heated to a precise temperature, turning it into a viscous liquid. Now imagine pushing the syringe's plunger, forcing the molten plastic through a narrow channel and into the waiting mold cavity. This is where the magic happens. The mold acts as a chilling chamber, rapidly cooling the molten plastic. As the plastic cools, it solidifies, taking on the exact shape of the mold cavity. Once the plastic has fully hardened, the mold opens, revealing the freshly formed plastic part. The entire cycle, from injection to ejection, can take mere seconds, allowing for rapid mass production. Injection molding is a symphony of precision, where every parameter, from injection pressure to cooling time, plays a crucial role in determining the final product's quality. It's a testament to human ingenuity, allowing us to create complex plastic parts with incredible speed and accuracy. Section 4. Anatomy of an injection mold, decoding the blueprint. An injection mold isn't just a hollow cavity, it's a complex assembly of precisely engineered components, each playing a critical role in the molding process. Let's dissect a typical injection mold and understand the function of its key parts. The heart of the mold is the cavity, the space where the molten plastic takes shape. This cavity is meticulously crafted to match the desired form of the final product. Surrounding the cavity are the cores, which form the internal features of the part, like holes or recesses. These cores and cavities work together to create the intricate geometry of the plastic product. Molten plastic enters the mold through a channel called the sprue, which then branches into smaller channels called runners, leading to the individual cavities. At the end of each runner are gates, small openings that control the flow of plastic into the cavity. These gates ensure that the cavity fills evenly and without trapping air. Once the plastic has cooled and solidified, ejector pins push the finished part out of the mold. These pins are strategically placed to apply force without damaging the delicate features of the part. The mold then closes, ready for the next injection cycle. Section 5. Mold Design, the art and science of shaping plastic. Designing a plastic mold is more than just replicating a shape. It's a delicate balance of art and science, where every design decision has a ripple effect on the final product's quality and the efficiency of the manufacturing process. One crucial consideration is draft, a slight taper applied to the mold walls. This taper ensures that the solidified plastic can be easily ejected from the mold without sticking or getting damaged. Another critical factor is wall thickness, which influences the part's strength, rigidity, and cooling time. The placement and size of gates are equally critical, affecting the flow of molten plastic and the potential for air traps. Improper gating can lead to incomplete filling, surface defects, and structural weaknesses in the final product. Mold designers must also consider the material properties of the plastic being used, as different plastics have varying shrinkage rates and cooling behaviors. Mold design is a complex puzzle where every piece must fit perfectly to ensure efficient production and high-quality results. It's a testament to the ingenuity of engineers who meticulously craft molds that shape our plastic world with remarkable precision and efficiency. Section 6. Conclusion. Molding a better future. Plastic molds, often hidden from view, are the unsung heroes of our modern world, shaping countless products that we rely on every day. From the mundane to the extraordinary, these meticulously crafted tools play a crucial role in driving innovation and shaping our future. As technology advances, so too does the world of plastic molds. New materials, manufacturing techniques, and design software are constantly pushing the boundaries of what's possible, enabling the creation of even more complex and intricate plastic parts. From lightweight, high-strength components for aerospace applications to biocompatible implants for medical advancements, plastic molds are at the forefront of shaping a better tomorrow. Their versatility, efficiency, and precision make them indispensable tools in a world increasingly reliant on plastic. So, the next time you pick up a plastic product, take a moment to appreciate the intricate world of molding that brought it to life. These unsung heroes are silently shaping our future, one injection molded product at a time.